Okay, grade 8 review for ratios, rates, and proportional reasoning. So this chapter was only 3 sections. First section was on ratios, second section was on rates, and the third section was on proportional reasoning. So these 9 questions are just 9 basic questions that you can do to review for your test. Even if you've done them once, it would help to do them one more time just to kind of practice to make sure you understand the procedures for each question. So the first question gives you a picture that says make a P to P and a P to W ratio. So P to P stands for part to part, and a P to W stands for part to whole. And if you go back in time to when we first learned this a couple weeks ago, we said a part to part ratio examines one part of a picture to another. So in this case, you could do stars to circles, and that would be one, or you could do circles to stars. You can do either one. But if you write down stars to circles, you would have to put 1, 2, 3, 4, 5, 6 for stars, and you would have to do 3 to circles. So there are 6 stars for every 3 circles there are, and that's a part-to-part ratio. But you can also express ratios in lowest terms by dividing each term by, 3. And therefore, you could say in lowest terms, the ratio of stars to circles is 2 to 1. That means for every 2 stars there are in this picture, there will be 1 circle. So the answer for a part-to-part could be 6 to 3. You might have 3 to 6, which would then reverse them to be 1 to 2. It's up to you, but there are only 2 choices for that. In the second part, part-to-whole ratio, you could still take stars, but this time our second term of our ratio can't be another part of it, but it has to be all of it. So we're going to put all of it or the whole thing. So in this case, we have 6 stars to all figures, which is 9. And 6 to 9 could be written as that, or it could be written like this. Or because it's a part-to-whole ratio, it's usually best to examine it as a fraction, because a fraction is a part-to-whole ratio. And therefore, in lowest terms, we can divide both by 3. We would have 2 to 3, meaning for every 3 objects in the picture, 2 of them are stars. We could also reduce it like we would normally a fraction and say for every 2 stars, there are 2 stars for every 3 shapes in the picture. So that's a part-to-whole ratio. And the second question says, what is a part-to-part and a part-to-whole ratio for this class? Now, there's a whole bunch of different ways you could have done this. Now, probably one of the more common ones would be comparing boys to girls or girls to boys. And I don't know how many there are, but we'll just pretend there's 12 boys and 13 girls. So the ratio, the part-to-part ratio for boys to girls would be 12 to 13. Okay? And a part-to-whole, you might have done chairs too. You might have done lights to tiles. You might have done big desks to small desks. It was up to you, blue chairs to black chairs, or whatever you wanted to do. But for the part-to-whole ratio, this is the part-to-part. For the part-to-whole ratio, if I use the same information here, I could do one of 2 different ones. I could do boys to the class, which would be 12 to 25, or I could do girls to the whole class, which would be 13 to 25. And remember, to get the all, I had to simply add my boys plus my girls to get the all part of my part-to-whole ratio. And because it's that, I could then express it as a fraction. And all fractions have an interesting quality to them. If you have fractions or if you have part-to-whole ratios, you could also make equivalent part-to-whole ratios that express percentages. Because a part-to-whole ratio is a fraction, you could also say that 48% of the class are boys. All right, that's something else you could do. Question 3 says, Kale reads 900 words in 5 minutes. Give 2 unit rates for this. So usually, you would create a rate and then a unit rate from this. So the words to minutes is going to be the standard rate of reading, right? You're not going to say minutes per word. You would do words per minute. So in this case, you'd have 900 words in 5 minutes. This is called a rate. This is just the rate of reading, the rate of speed he has for reading, 900 words in 5 minutes. But a unit rate, by definition, a unit rate, the second term is 1. one of whatever unit it is. So in this case, if I want to make it 1, I could make it 1 minute. That would be a unit rate. And I could achieve this by dividing both sides by 5. Take my calculator out. 900 divided by 5 is 180. So therefore, one unit rate you could use would be 180 words per 1 minute or per minute. Now you could also take that unit rate of 180 words in 1 minute and you can create a second unit rate. And you could either divide both by 60. In this case, I'm going to divide both by 60 because 1 minute divided by 60 is 1 again. But this time it's 1 second. And 180 words divided by 60 is 3. So a second unit rate you could have made is 3 words per second. That is a second unit rate. Now you might have also chose, instead of divide by 60, you could have multiplied by 60 to get, instead of 1 minute times 60, that's going to become a unit rate again, but this time it's going to be 1 hour. And 60 times 18, 60 times 180, so 180 words a minute multiplied by 60 minutes in an hour will tell me he can read 10,800 words in 1 hour. Okay, those are 3 examples. You could also do a day, you could also do a year, you could also do a week. It's up to you, but those are 3 of the most common unit rates you probably would make from that information. And the fourth question says milk's $1.40 for 500 milliliters. Give 2 unit rates. So again, we're going to do the cost for volume of whatever object it is. We're talking about milk this time. So $1.40 for 500 milliliters is a rate. That's the rate or the cost for that milk. Now the unit rate, remember we said before that a unit rate is 1. So in this case, we're going to do 1 liter first. And 1 liter is really, in brackets, 1,000 milliliters. So in order to go from 500 to 1,000, I'm going to multiply by 2 and multiply by 2 to get $2.80. So 1 unit rate you might make from this is it would be $2.80 per liter. And that would be an example of a rate. Now another one that's a little less common, a little bit more confusing, is the fact that I could divide both by 5 to get 100 milliliters. And by doing that, I'd get 20 cents and 8 cents. I get 28 cents per 100 mils. And somebody might say, well, hold on, you just told me a unit rate is per 1, and 100 milliliters is not 1, it's 100. But it is actually a unit rate because 100 milliliters in our metric system is actually 1 deciliter. Even though we don't use deciliters very often, it is still a unit of 1, but we'll call it 100 milliliters. In the next question, says a jet travels 3,124 kilometers in 4.5 hours. What is its speed? Well, the rate of speed is this. This is actually its rate of speed. It travels this fast in that much time. But what we're really looking for, again, is this unit rate idea. How fast was it going per 1 hour? Now it says, what is its speed? So there's 2 ways we can do it. The first way, of course, is to figure out what I would divide by to get that, so I could divide both by 4.5. And when I take my calculator and go, the speed was 3,124 hours in 4.5 hours. So if I divide that by the 4.5, that means that every hour that plane was, oh, I forgot the number, was going 694.2 repeating kilometers per hour. So its rate of speed was 694-ish, approximately, kilometers per hour. Okay, that's one way to do it. Just divide both terms by a common number to get to 1. Now, we could have also used the idea of proportional reasoning. And that's an interesting one. So x over 1, I could multiply across this way to get one side of my algebraic equation. I could multiply the other way to get the other side. And interestingly enough, if I'm going to isolate, I'm going to divide both sides by 4.5. And if you think about what I did here, I did the exact same thing. I divided 3124 by 4.5, and I'm getting x equals 694.2 repeating, and therefore it's the same answer. So this is called proportional reasoning, I like to call it the cross multiplication method. And this is called the unit rate method by simply dividing both terms by a common number. In your next question, you're given two costs for liquid. The first one is $2.80 for 200 milliliters versus the second one, which is $3.75 for 375 milliliters, which is the better deal. So in this case, we're going to convert both of these to unit rates, so they're comparable. So I want to know how much it is per set amount. Now we said before that if you go to 1 milliliter, it's going to be less than a penny. So we don't want to do that. We want to get it down to per 100 milliliters, which again, like the last question I said, was actually a deciliter. So this one would have been $1.40. So A would have been $1.40 for each 100 milliliters of that liquid. In the second one, it's $3.75 for 375 milliliters. Now, some of you aren't going to know what you divide it by to get 100, right? It's 3.75. So if you don't know, you can do one of two things. You can get it down to 1 milliliter first, and then figure out what 100 mils. This is a unit rate to a different unit rate. And I would divide both by 375. The only problem is when I take $3.75 and divide it by 375, I get 0.01, 0.01. Now that means it was 1 penny for each milliliter. And therefore, for 100 milliliters of that, it would be $1. So the second one was $1 for that same amount, 100 milliliters. And therefore, which is the better deal? B is the better deal, right? This was cost me $1.40 for every 100 milliliters I bought of that liquid. And this one only cost me $1 for every 100 milliliters of that liquid. Next question is simply a reasonable proportion. It says X per day is equal to 84 per week. So there's a couple different ways you can solve it. The easiest way is, since it's 1 day, I know that if I multiply that by 7 and multiply this by 7, I would get 84. So the question is, what number did I multiply by 7 to get 84? You could figure it out that way. Or, conversely, if I divide this by 7, 1 week divided by 7 is a day. And if I divide this by 7, that's an easier way to think about it. So 84 divided by your 7 is 12. So therefore, X would equal 12. So if you had 84 of something per week, you would have 12 per day. Therefore, it is 12 per day. Question 8. It's $1.50 for 12. How much is it for 13? It says use two methods. So the first method we're going to use is going to be that unit rate method. So if it's $1.50 for 12, I want to know how much it is for 1, and then I want to know how much it is for 13. Here I would simply divide both terms in my rate by 12. Take my calculator and say, well, what is $1.50 divided by 12? It is 12.5 cents, or 0.125, or I could round that to 13 cents, I suppose, but we'll keep it 12.5 cents. And then to get it to 13, I would multiply both by 13. Take my 12.5 cents and multiply it by 13 of those units to get $1.62.5 cents, or approximately $1.63 for 13. That's one method. This is called the unit rate method. Taking this down to 1 and then bringing it back up to whatever number I need to examine it in. A second method is to simply use proportional reasoning. So $1.50 for 12 is equal to X over 13. I could multiply both sides crossways to create an algebraic equation. 12x would equal the product of $1.50 and 13. Oh, multiplied by 13, which is $19.50, or 19.5. I don't want to say dollars. Divide both sides by 12. And 19.5 divided by the 12 will give me the same answer as over here, right here, which is $1. X equals $1.62.5, or approximately $1.63. And finally, your last question. The last question says, Cale runs 50 meters in 5.87 seconds. How fast was he going in kilometers per hour? So this is the question we did outside today. So 50 meters in 5.87 seconds. How fast was he going in kilometers per hour? Well, I know that since this bottom term is seconds and I want to do it in hours, I can't put seconds in hours, so I have to convert hours into seconds. Since there are 60 seconds in a minute and there are 60 minutes in an hour, there are 3,600 seconds in that 1 hour. So I'm going to use 3,600 as my bottom number instead of 1. I need to make sure that my units are the same. This is going to be x meters over 1 hour. So you could use a unit rate. You could break this down into how many meters he was going in 1 second, and then you could figure out in 1 minute, and then you could figure out in 1 hour. That will work. So let's just see if we can do that. We're going to divide both by 5.87 in the unit rate method. So take my 50 meters divided by 5.87, and that tells me he was going approximately 8.5 meters every second. I'm then going to multiply both of those terms by 60. Grab my calculator. So take that number and multiply it by 60. He would have then roughly went 511 meters in 1 minute. I'm going to multiply it by 60 again. Multiply it by 60. It tells me he was going roughly 30,664 meters in 1 hour. So the answer is the unit rate is 30,644 meters per hour. Or since 1,000 meters equals 1 kilometer, it would be 30.6-ish, I can go 4, I suppose, kilometers per hour. Okay, so Cale was running roughly 30.644 kilometers per hour because this many meters is this many kilometers. That's one method to do it. That's the unit rate method. The second method, of course, is to keep it as, oh, by the way, I forgot to say, the formula for speed, the reason why we put distance on top is because speed, the formula is distance over time. So in Cale's case, the distance he ran was 50 meters, and the time he took was 5.87 seconds, will be proportional to how many meters in 3,600 seconds, which is 1 hour, multiply across to get 5.87x, multiply across the other way to get 180,000. So now I have my equation that I can create from this proportion. Divide both sides by 5.87, and x will equal, it should be 30,644. I'll just double check though. Make sure my answer is right. So 180,000 divided by the 5.87 still gives me that same answer there. So therefore, that's how many meters he was running in 3,600 seconds or 1 hour. So then the same process that I went over here happens again. So you can either do it using the unit rate method or using proportional reasoning cross multiplication. Okay?